Hey folks, today we're going to talk about the modern periodic table. This is a rather long podcast. More importantly, there are a lot of pictures of periodic tables in here. You need to take notes on this podcast. There's a lot in here you've got to write down. Okay. This is your standard periodic table. This is what you have a copy of. It looks a lot like the one that you have that I give you in class, right? That you'll be able to use on every quiz and every test for the rest of the year, right? But there are many different forms of the periodic table. They can look like this. And we'll be talking about this one in just a minute. They could actually look like this. Right? Now, if you go back just a minute, let's just for a second just look at what we can do. Sorry, go back here. Notice that over here on the right-hand side, you should already be familiar with these. These things over here are called the noble gases. Right? But look at helium and neon and argon. I'm just going to remember those just at the top of your noble gases so that we can look to see where they are on some of these other cool periodic tables. You'll notice here's hydrogen and helium. They're not even attached to anything else, right? But when we look for the noble gases, we're going to look around and we find the noble gases right here, right? So we have neon, argon, and krypton right there, and xenon and radon. They go all the way down there, right? But your noble gases, for whatever reason, whoever designed this periodic table decided they weren't going to touch anything else. That's an interesting observation. We'll look at that a little bit later. Right? Now here, you'll notice that hydrogen and helium are in the middle, and here helium is attached to all the noble gases. Those are the ones here in yellow. Right? And then they have a lot of other strange organization for some reason, which we're not going to get into right now. But it is interesting that they keep all the noble gases together, and that's true for your main block elements. Okay? Over here we have the same thing. There's hydrogen, here's helium, and if we look over this way, and I realize it's kind of hard to see, but that's argon right there, and that's krypton right there, argon, that's neon. So they do have, again, all the noble gases still together, and they do that for all the other elements. So it's just a different layout for whatever reason they choose to do this. And we'll talk about why some of those happen. Okay, but this is the periodic table that you're going to use for our class. Okay, so when Mendeleev organized the periodic table, and since then we've made it more modernized and made it nice and pretty, but when he did that, he said they have groups and they have families, and those terms are synonymous, and they're things that go. Sorry, my pen is not working. Let's try that again. They go up and down, and they're things that have similar properties. So when we look back here, we'll say that all of these over here, neon, argon, krypton, xenon, radon, are all noble gases. They tend to not bond with anything. They're all similar, so they're all one above the other. Periods go left to right. So the way that I used to teach this to remember it is when you're trying to think of periods, think of a 7-period school day, right? And then go back and look at your periodic table and notice that you do have 1, 2, 3, 4, 5, 6, 7. We're going to ignore these for now. We have 7 rows going straight across the periodic table. We've got a total of 18 columns. Again, not ignoring these ones at the bottom, we have 18 columns. So if we think of periods, the periods go across this way. Right? And your columns or your groups go up and down, right? Because the groups have similar properties. Now, if you haven't taken out your periodic table yet, I suggest you do that and start taking some notes on it because you're going to need them as we go on. Okay, so pause the video, take out your periodic table. Okay, so some of the things, the organization of our periodic table is that it has 109 to 118 squares. Now if you look back at our periodic table, it really does have 118 squares. Now you'll notice there's some down here that never got filled in. And for whatever reason on this particular periodic table they haven't filled these in. When this periodic table was made, they didn't have an element 113 or 115 or 116 or 117 or 118. And frankly, they still don't have some of those. They're still trying to create them. The problem is when they create them in the lab, they only last for 1,000th or even 1,000,000th of a second. So then the question is, did they really create it? So, but anyway, there are a total of about 118 squares on our periodic table. Each one represents a unique element. And the shape of our periodic table is in part from the periodic law. And if you remember from our previous podcast, the periodic law talks about when elements are arranged in order of increasing atomic number. Remember, that's the number of protons that they have. Mendeleev didn't know about atomic numbers. Their physical and chemical properties show a periodic pattern. So that's exactly what we're seeing, is we're seeing periodic patterns as we go through our periodic table. Remember, periods are horizontal. Okay, and as you go down, each period has more and more elements. So let's look at our first period right here. Our first period, we only have hydrogen and we have helium. So we've only got 2. But on our second one, we've got 2 over here. And then when we look over here, we've got 6 over here on the right. So we have a total of only 2 up at the top, and we have 8 here. Now, in our third row, we also only have 8. So in our third period, we only have 8. But in our fourth period, we have a lot more. We have 2 here. We have 10 there. Plus, we have 6 more way over here. So 6 plus 2 is 8, plus 10 is a total of 18. And we also have 18 going across in period 5. Now, what about period 6? Well, we'll get there in just a second. Because when we look at period 6, we notice that our numbers jump from number 56 to number 71. Well, what happened to numbers 57 through 70? Well, I have this little star down here. Right? So what's really going on is this whole set of the table that's down here doesn't belong down there. It really belongs right up in here. So here's number 57, and it should be right next to number 56. And then 58 and 59, etc. All the way out to the right, which is number 70, which should be right next to number 71. So really what we have to do is take the periodic table right here and split it and stick in these 14 columns right up in here into these 2 positions right there. If we did that, our periodic table would look like this. And that really is the way our periodic table does look. Our modern periodic table does have these 14 rows sitting right in here. Then why don't we draw it that way? Why do we draw it this way? Well, frankly, because that will not fit on a piece of paper easily. This will fit much better. So that's the way we draw our periodic table. Okay? Sorry, that's just the way it is. So let's look at some groups. We label and name the groups. So we have some labels. Specifically, the IUPAC has some labels and CAS has some labels. But I just want you to be familiar with them. Notice up here above our group, we have the number 1. Above this column. And above this column, we have the column number 2. And above here, we have a 3. And above here, we have a 4. We can do this all the way out until we get way to the right where we have a total of 18. Remember we talked about 18 columns? That is one way to label our columns. That's the IUPAC way of labeling our columns. Now there's a whole other way to label our columns, which is looking at CAS names, which is 1A, put arrows to those, 2A, and I'm going to jump way over to here, which has 3A, and then 4A, all the way up to 8A. So from the CAS system, they only have 8 blocks labeled, and the reason for that is these 2 columns that are over here on the left, and these 6 columns that are over here on the right, we call these the main block elements. And we kind of ignore these guys in the middle. Notice how all these guys in the middle all end in B's. We have a 3B and a 4B and a 5B and a 6B, etc. They all end in B's. Right? So that, and notice we start with 3 and over here are 1 and 2, and that can get real confusing. So really the easiest way to number these is 1 through 18. And that is typically the way I will do it. Or I might refer to 1A, 2A, 3A, up through 8A when I'm only talking about the main block elements. Okay. Or I talk about that a little bit more in a future podcast. Okay, we do have some group names that you need to know. So again, you're going to have to pause the video in here and write some stuff on your periodic tables to make sure that you know what certain names are. Okay. For example, here you have the alkali metals that are all outlined in yellow. Now notice one thing that's missing. Hydrogen is not an alkali metal, yet it's in that group. Well, that's too bad. We don't consider it an alkali metal. Remember, one of the periodic tables that we looked at didn't even have hydrogen connected to the periodic table, to everything else? Well, that probably was a good idea, because helium is often the same way. Sometimes hydrogen really should be over here above fluorine, based on the way it works, and sometimes it should be where it is. Helium, on the other hand, sometimes should be where it is, and sometimes would appear better over here. So for different reasons, we kind of let hydrogen and helium kind of float over the periodic tables. So if I look at group 1, also known as group 1A, we call them the alkali metals. That's a name you need to memorize, so make sure you pause the video and write that down. The second group you need, oh, sorry, I just said that. Hydrogen is not connected to the periodic table. Alkaline earth metals, column 2 or column 2A, depending upon how you want to phrase it. 2A. Those are your alkaline earth metals. Again, a name you need to know. The halogens are way over here. These are in group 7A or 17. Again, I don't care which way you do it. 7A or 17. These are halogens. And then over here on the right-hand side, the final one are the noble gases. Okay? And that includes helium. Helium is a gas that is considered a noble gas. Now, there are all sorts of other groups. What about this group right here? What would we call it? Well, we tend to call it the boron group. Why? Because it starts with boron. So what do you think we would call the group next to it? Sure, we call that the carbon group, and the nitrogen group, and the oxygen group. So that's what we just call them, for lack of a better term. We don't want to make up a bunch of names for things we wouldn't use often. Okay. Now, there is something that you need to make very sure that you highlight on your periodic table. So look at your periodic table and you look right here, in between boron and aluminum, and you'll see a very dark line. Sorry, I'm going to try and draw this without messing up. And it goes in a stair step all the way down here and ends up between astantine or astantine, or however you pronounce it, and polonium. Right? You need to know where this line is. You need to be able to find this line on your periodic table. And on your periodic table, at least on the one I give you in my class, there is a line there. Right? If you're using a different periodic table, make sure that you mark that line in somehow dark so that you can see it. We call this the semi-metal line. It is the line that separates the metals, and we're going to talk about these a little bit more. Metals over here on the left from the non-metals. Okay. So, let's go look at that. A metal is something like zinc. All right, well, let's go back to our periodic table. Where is zinc? Well, zinc is to the left of that stair-step line. Zinc is right here. So if I look at zinc, zinc is a metal, and there's certain characteristics of metals that you need to know. We've talked about these before, but you need to make sure that you understand that they are shiny. And they're typically silver, copper, and gold are not, but the rest of them are typically shiny to silvery color. They're good conductors of heat, they're good conductors of electricity, and they're typically solids at room temperature. If you look at the periodic table in our classroom, you'll notice there is one metal that's blue. And blue signifies that it's a liquid at room temperature, and that one would be mercury. But all other metals are solids at room temperature. They're malleable. What does malleable mean? You should know that term by now. Malleable means you can flatten it, you can pound it into a sheet with a hammer. Right? And the other one's ductile. And ductile means that you can, just like the zinc, you can pull it into a wire. Right? So if you think of copper, which is your most common wire, also some are made out of aluminum. Right? They're metals. So you'll notice over here in green, everything that's in green is a metal. Okay. So that's part of, it's kind of a, those right there, and then I'm going to kind of just go down here and not do a great job. All of these things way down here at the bottom, those are also metals. These are all metals. Now you'll notice that hydrogen is not part of this, because hydrogen, as we said, for some reason, for some purposes, really belongs more over here with the halogens. Okay, because it is definitely a non-metal. Think of hydrogen as a gas, it's not a metal. Alright, so our non-metals, one of our non-metals is sulfur. They have no luster. They have no shine. They are typically poor conductors of electricity. You can't pound them into a sheet or pull them into a wire in this case. Sulfur is kind of like a dust. It's a powder almost. It's not even a rock, right? It's more of a powder. Many nonmetals are gases at room temperature. For example, neon is a gas. Some are solids, like sulfur. Some are liquids. They have many varied properties. Some are colored, some are colorless. Some are soft solids, some are hard solids. So again, look at the right-hand side of your periodic table over here, and you'll notice these things over here in gold. Things in gold, along with hydrogen. Remember, can't forget hydrogen. Hydrogen belongs over here. Okay, these are nonmetals. So that leaves the blue ones. And the blue ones are semi-metals, or metalloids, and an example would be silicon. It has some of the properties of metals, like it's shiny. It has some of the properties of nonmetals, or they're kind of in the middle and intermediate. So for example, silicon is what's called a semi-metal, and it's also a semiconductor. Under certain circumstances, it will conduct electricity, and under certain circumstances, it will not. Hence, it's termed semi-metal. It is a principal component of computer chips. Antimony can be found in matches. That is another semi-metal, and arsenic is a poison. So if I look at this, there are a total of seven semi-metals, and when I look at them, they all touch this stair-step line. Now, there are other things that touch this stair-step line too, right? For example, you look all the way at the top, and aluminum touches the stair-step line. Aluminum is definitely a metal. So the blue things are nonmetals, or metalloids. Okay, you just need to know where they are and how to find them. Okay, you don't need to memorize exactly what they are, at least not yet, right? But you do need to know where to find them. Okay. All right, we have a couple of more names you need to know. You need to know the main block elements. We already mentioned that. We're going to talk about the transition elements, also known as the transition metals, and the intertransition metals. All right, we mentioned earlier that groups 1 and 2, the things that are labeled 1A and 2A, those are main block elements. And the things over here on the right, which are your, I lost my pen. Come back here, please. Thank you. These guys over here, these are also main block elements. Right. Now, things in the middle, all of these things, these are called transition metals. And they can just be called transition elements. Transition metals. Okay? But because they're all metals, they can be called transition metals. These things down here, these are the ones, if you remember, they're the ones that fit up into here, into these two holes that are right here. Right? And we separate out the periodic table. Well, those things are called inner transition metals, and they're inner because, guess what? They fit inside inner transition metals. Because they fit inside the rest of it and shove the periodic table apart. All right, so in summary, you need to know what a period is. Remember, a period goes left to right, a group goes up and down. We have group names, alkaline metals, the alkaline earth metals, the halogens and noble gases. Then we have other groups like the carbon group, the, et cetera, the bromine group. Okay. You need to know that metals typically have a luster or a shine, that they conduct heat and electricity. Metals are typically solids, and everything else could be nonmetals, sometimes solid, sometimes liquid, sometimes gas. Malleable. Things can be pounded into sheets. Those are metals. Metals can be drawn into wire that are going to conduct electricity. Those are ductile. Semi-metals contain some of the properties of metals. Sometimes they have a luster, sometimes they don't. Sometimes they conduct electricity, some don't, etc. Okay, they have some properties of each. Okay, main block elements, those are the ones on either end. Transition metals, and then your inner transition metals are the one down at the bottom. We'll talk about those a little bit later, I think, in our next podcast too. Okay? Make sure you go off and do some practice, do the worksheet. Hopefully you've been taking notes, and because we're going to check in the class, and we'll see you in class. Have a great day. Bye.